Hi, Calc friends. Here we go, week 10. So this is going to be number 19. If you take a look at your differential equation, you got a point for your zero slopes and your point for any of your other slopes that were supposed to be negative or positive. Okay, so I felt like that was pretty good. For part B, you're doing Euler's method. And if I calculate dy dx given 0, 3, the point that I'm starting at, my dy dx is going to be 0, and 0 times that dx is still going to be 0. So my next point is going to be 0.1, comma 3. So there's no change in your y value. So we'll start that and go with 0.1, comma 3. And to calculate dy dx, I end up with 0.3 divided by 2, which is 0.15. And I'm going to take 0.15 and multiply that by my 0.1. So that's going to be 0.015, and that's my change in y. So now I have 0.2, comma 3.015. Now, some people just left it. We're not leaving the table as our final answer. We were asked to approximate f of 0.2, so I will write f of 0.2 is approximately 3.015. Okay, so that's how you got your full points with Euler. Okay, first of all, you got to make sure that you have the approximate, and you need to have that there. For part C, it asks for a particular solution to y equals f of x to the given differential equation with the initial condition. So here's our initial condition. Use your solution to find f of 0.2. So I have dy dx is equal to xy over 2. And if I separate variables, that means I'm going to have 1 over y dy is equal to x over 2 dx. And if I integrate, I'm going to get the natural log of the absolute value of y is equal to 1/4 x squared plus c. Okay, now we had some people solve for c here. Please be careful in doing that. I highly recommend not doing it because of just for simplification purposes. I'm going to raise e to all of this, and I now have the absolute value of y, which is equal to c times e to the 1/4 x squared. Okay, now having that absolute value of y allows for the opportunity for c could either be less than 0 or it could be greater than 0. Okay, so I have to keep that in mind. So when I plug in my ordered pair, I'm going to get 3 is equal to c e to the 0. So I know that my c value is equal to 3. Okay, so I know that this function is y equals 3e to the 1/4 x squared, and I'm supposed to plug in 0.2. So I'm going to have y equals 3e to the 1/4 0.2 squared over 4, which is literally y equals 3e to the 0.01. Okay, and if I actually calculated that, which I think this was, is this a no calculator one? Yeah, this was a no calculator one. So you could just leave it like that and be done. Okay, but what they wanted to show you is that this right here, 3.015, this actual answer is 3.030. Okay, so you could have left it at that. All right, that was worth 6 points. So if you did not simplify, or you told me that the original equation was e to the 1/4 x squared plus natural log of 3. No, you need to simplify that. I'm not taking that, and AP probably won't either. Okay. All right, let's go to this guy. This second one, problem number, let's see, 20. Okay, when they're talking about the two different equations, the 0.01, okay, that guy is literally on a straight line all the way through, okay? So that one was pretty easy. I know I had some people bending or trying to make it curve. Nope, straight line all the way through that 0, 1. The one that goes through 0, -1, that guy we had some bending. So in order for me to get there, and then I'm coming back down around. Okay. And that was 2 points. For part B, again, you're doing a table, right? So you're starting at 0, 1. So if I make my table 0, 1, and I know that dy dx is equal to, what did they tell me? 2y minus 4x. And then I'm going to multiply by my step size of 0.1. So I'm going to multiply by dx, the change in x, which is 0.1. And then I'll get my new ordered pair. So 0, 1, that means that my derivative is going to just be 2. And if I multiply that by my delta x, right, by 0.1, that's going to be 0.2. So now I'm going to have 0.1 comma 1.2, and I'll come down here, 0.1 comma 1.2 dy dx is going to be equal to 2, and I have my dx, multiply that 0.2 or 2, I'm going to get 0.2, and then I'm going to end up with 0.2 comma 1.4. And again, my approximation f of 0.2 is approximately 1.4. Okay, done with that one. For part C, I had a lot of people just use the initial condition, which was 0, 1, to solve for B, but you can't just use 0, 1 because we have to go through all the points or in general, so there had to be some sort of proof. So what we could do is we have this right here, and we also have that dy dx is equal to 2y minus 4x. We can substitute this right in here. So I end up with 2 times 2x plus b minus 4x. Okay. And then what ends up happening is that I get that 2 is going to, or sorry, b is going to be 1. And then that was the verification that they were looking for. Okay. And then the other option was to guess, which some of you said, okay, b equals 1. So now what they wanted you to do, all right, so y equals 2x plus 1, okay? But then they wanted you to verify that 2y minus 4x, okay, is going to be equal to 4x plus 2, which is equal to 2, which is dy dx, because it's the slope. Okay. All right, for part D, that was worth 2 points. And then this would have been slope is equal to 2. There we go. So we know that the slope is equal to 2 based on this. That dy dx was 2. Okay. For part D, this was worth 3 points. Okay. Yeah, g prime of 0 is equal to 0. But how do I check to see if there's a local max or minimum? Okay. How about second derivative? So some of you were like, oh, I can tell by the graph, and you were just taking into consideration x values, okay? But in differential equations, we need to go find the second derivative. So let's go find g double prime of x, because if I have either negative or positive, it tells me what my local max or local min, when is that happening. So if I take the second derivative, that's going to be 2 times dy dx minus 4, according to my first derivative. And if I evaluate g double prime of 0, right, then I'm going to get 2 times g prime of 0, because that's the derivative, minus 4. So I end up getting negative 4. So, yes, there is a maximum at 0, 0. Since g prime of 0 equals 0 and g double prime of 0, is less than 0. Done. There's your justification. Okay. End of story. All right. See you next week.